welcome back to another Physics in the Flesh installment, Wave Energy. The intensity of an earthquake wave passing through the Earth is measured to be 1.9 times 10 to the 6 joules per meter squared seconds at a distance of 46 kilometers from the source. Part A. What was its intensity when it passed a point only 1.0 kilometers from the source? And B. At what rate did energy pass through an area of 5.1 meters squared at 1 kilometer? So for part A, what was the intensity when it passes a point only 1 kilometer from the source? So we're looking for the intensity at this distance. The question gives us this intensity at this distance. So you should already start thinking this is like a ratio. But before we jump into the math, I want to quickly go over some theory about waves and how to use this in a formula later on. Okay, so imagine this is the source of your wave. Okay, if we consider the wave going out in one direction, two-dimensionally, we see the wave crest moving out as circles, right? And they move outwards. Okay, so a two-dimensional wave, you have circles getting larger. In this case, it's an earthquake. So we're not really dealing with the two-dimensional system here. We have a three-dimensional system. So you don't have circles, you have spheres going out in every direction. And these spheres are getting bigger and bigger and bigger. And they're going every which way. Okay, so a three-dimensional wave, you have spheres getting larger. And the reason why we have to identify that it's a sphere and not a circle is for the next part. Okay, since we're dealing with intensity, and that's what we're actually looking for, intensity is given by the power from the source divided by the area. And because we're dealing with a sphere, the area of a sphere, or rather the surface area of the sphere, is given by 4 pi r squared. So I is equal to P over 4 pi r squared. Okay, so the next thing let's do is comparing intensities at 2 points. Okay, so if we wanted to compare two intensities, I've already got the formula for intensity. Now I'm going to compare intensity at a location 1 compared to a location 2. Just use this formula. So P1 over 4 pi R1 squared divided by P2 over 4 pi R2 squared. Okay, first thing you can cancel out is that, well, there's a 4 pi here and here. And to see that these actually cancel out, remember when you have a fraction in the denominator, you can flip it and multiply it to the numerator. Okay, so the 4 pi would be in the numerator up here and they would cancel. Okay, the next thing is that because the source is the same, it's the earthquake. Okay, so the power output from the source is constant. And because of that, we can state that P1 equals P2. So if that's the case, these also cancel. Okay, so what are we left with? Well, we're just left with this expression now. I1 over I2 is equal to R2 squared over R1 squared. Okay, and we're going to use this to solve part A. What was the intensity when it passes a point only 1 kilometer from the source? Okay, so let's just move into part A here. So for part A, we're looking for the intensity nearby, so I'll call that I1, where R1, the near distance, is 1 kilometer or 1.0 times 10 to the 3 meters. Okay, my intensity at the further source, I2, is 1.9 times 10 to the 6 joules per meter squared seconds. And the distance for that intensity is 46 kilometers or 4.6 times 10 to the 4 meters. So we take all of this and incorporate it into this formula right here, this one. Okay, so let's do that down here. I1 is equal to I2, R2 over R1, and these are both getting squared. Okay. So I can actually take this because both the top and the bottom are being squared. Let's just stick it into brackets and then square the entire bracket. So R2 over R1 all squared. Now you just plug in your numbers. I2 is 1.9 times 10 to the 6 joules per meter squared seconds times R2, 4.6 times 10 to the 4 meters divided by R1, 1.0 times 10 to the 3 meters squared. Okay, So the meters squareds will cancel, and you're going to be left with the unit for intensity, which is what you want. And you end up with I1 is equal to 4.0 times 10 to the 9 watts per meter squared. Okay, so there's your answer to part A. Now finally, for part B, at what rate did energy pass through an area of 5.1 meters squared at 1 kilometer? Okay, so the key to understanding how to solve this is the part in the question that says, at what rate did energy pass? Okay, so rate is usually with respect to time. Okay, that's how we describe things in physics. The rate of distance with respect to time, right? The rate of speed with respect to time. Here it's energy. Okay, the rate of energy, and it's going to be with respect to time. Energy over time, this is the formula for power. Okay, now in this case, because we're dealing with intensities, I'm not going to use this formula for power. I'm going to use the one that we actually identified in the beginning, also that was in the same color. Power is equal to the intensity times the area. Okay, so intensity, we just found it's 4.0 times 10 to the 9 watts per meter squared, right? That's the intensity at 5.1 meters squared area at the 1 kilometer distance, and the area it's going through is 5.1 meters squared. So you get your meter squareds canceling, you're left with watts, which is the unit for power. So power is 2.0 times 10 to the 10 watts. And there you have it, guys. I hope you guys enjoyed the video. Be sure to smash that like button if you did, and subscribe to my channel so you never miss a video from me. I post videos every weekday at 12 noon, so stay tuned tomorrow for video 141, Standing Waves and Resonance 1. What? Wait, who's back to school? Pumpkin pie recipe. Okay, I'll save that for Halloween. Guys, so that's it for this video. I hope you enjoyed it. If you did, be sure to smash that like button and subscribe to Physics in the Flesh so you never miss a video from me, which, by the way, I post every weekday at 12 noon. So be sure to be on my channel at that time. Guys, as always, if you missed my videos from the past, be sure to click over there on the right. You'll see some of my latest videos there. And other than that, guys, I hope you enjoy the rest of your day. Peace.